Card 9. Find domain algebraically. Remember that domain is the x values. It says to find the domain of an algebraic equation, ask the question, are there any restrictions on the input values, which are going to be the x values typically. Which means, are there any numbers that will not give an answer when plugged into the equation? Here are some possible restrictions and things to pay attention to. Number 1, 0 in the denominator of a fraction is not allowed. What input values or x values give the denominator a 0? Okay, we can't have zeros in the denominator. The second one, square roots. The expression under the square root cannot be negative. It has to be greater than or equal to 0. Well, that tells us exactly what we're looking for, but I'll go through these steps here. A, are there any fractions or square roots in the equation? Let's just look at example 1. Looking at example 1, looks like we have a trinomial x squared minus 6x plus 9. It says, are there any fractions or square roots in the equation? No. I'm done with that one. B says, if yes, well, I didn't. So, well, it said if no, then it's all real numbers. So I skipped this part. So right here, for example 1, there are no restrictions. It's all real numbers. Example 2 has a fraction. Okay, so if it has a fraction, B says if yes, the equation has a fraction in it, and I'm not going to read all this. Basically, if it has a fraction, this bottom, the denominator, cannot be 0 ever. So what I want to do is, I want to find the restriction itself. So if I take the denominator, which is x plus 5, and set it equal to 0. Why would I set it equal to 0? Because I want to know what x values is going to make this bottom be 0. So I subtract 5 from each side, and I get that x is equal to negative 5. What does that tell me? This is my restriction. This says that in my domain here, x cannot be a negative 5. So this is how I would write this in interval notation. I can go from negative infinity. When I'm writing my notation here, what I'm going to do is I'm going to go from the left to the right. So if I'm thinking about my graph where here's my x-axis and here's my y-axis, I'm going from left to right. So far left, that's negative infinity. Well, if I'm going from coming from negative infinity, how far can I go? I can go all the way up to the negative 5. And it is not included. The reason it is not included, the reason for the parenthesis, is because we can never set the bottom, you can never have x equal to negative 5. That's why we make this, we go from negative infinity to negative 5, close parenthesis. Okay. We can also have union. We need to talk a little bit about those union symbols. We can also have a union, which means and or plus. We can go from negative 5 to positive infinity. Now let's look at what we wrote here. What this is saying is that I can plug in any value for x except negative 5. Let's look at example 3. Again, we have a fraction. So since we have a fraction, the way we find our restriction is we set our denominator, which is x squared minus 6x plus 8 equal to 0. So how do we solve for x here? Well, you should know that whenever you have an x squared term and an x term, we have to factor. Now the way I teach factoring is I use Mustang Factoring, and the way it works is you're basically here, if you recall, you have an A, a B, and a C term. The A term is the number in front of the x squared term, which in this case is 1 because nothing's there. So A is 1. B is the number in front of x, which is negative 6. C is the constant. That's your first step in factoring. The next thing you want to do is multiply A times C together. Well, what is that? That's 8. 1 times 8 is 8. The next thing you want to do is you want to list all the factors of 8. In other words, what two numbers can be multiplied together to get 8? Well, obviously you have 8 and 1, then you would have 4 and 2, and that's it. Now, going back, for some of you this is what I taught last year. You know, you understand. Some of you may have seen it from other teachers. Some of you this may be new. This is what I'll be using to factor with all year, and so pay attention. We'll be doing quite a bit of this. This sign right here, it's positive. This tells me that my signs in my answer are going to be the same. This sign tells me what they're going to be. They're both going to be minuses. Now, what do I mean my signs? Well, if you recall, when you factor something, you end up with two sets of parentheses, right? And the variable that you're talking about goes first, like that. And so what I'm saying here is that my signs are going to be the same. They're both going to be minuses. They both go here like that. Okay? What does that have to do with these numbers here? Well, that means that since they're both minuses, each number, each set, the 8 and the 1 is a set, the 4 and the 2 is a set. They're both negative. So here's what we have. Both sets, negative 8 times negative 1 gives me positive 8. Negative 4 times negative 2 gives me positive 8. But which two numbers adds to get me negative 6? That negative 6 right there. And that's going to be the negative 4 and the negative 2. That's my answer. It's x minus 4, x minus 2. That's my factored answer. But we're not just looking for the factored answer. We're looking for what values of x will make this denominator over here be 0. So what I have to do is I set each one equal to 0. This is a review of Algebra 1. This is a review of Algebra 2. So you should be able to see that. Add 4 to each side, x equals 4. Add 2 to each side, x equals 2. There's my two restrictions. So since I have two restrictions, writing my restrictions in interval notation is going to be a little bit lengthier. Okay. So I'm going to start from the left. So I'm going from negative infinity all the way up to my first restriction, which is actually 2. Union, restriction to restriction, and they're both open because of the fact that these aren't included. But the reason this interval is here is because anything greater than 2 and less than 4 can be a solution. It can go into x and not give me a 0 on bottom. And now finally, union, my last restriction to infinity. Block that off so you can see what I've got. So that goes with example 3, and since this podcast is getting a little lengthy, I'll start a second to finish the final 3 examples.